Okay, welcome everyone. This is the Working Group Device Management meeting from June 4th. We have on the agenda a discussion of CAP 5075, the consumable capacities. There's still time to add other items, or I can just call out to the participants. Do you have anything else that you want to discuss? Nope. Then I guess that's what we'll discuss today. Bang, do you want to take over?
Yeah, thank you, Patrick. You hear me right?
Yes, we can hear you.
Yeah, I just want to give an update on the CAP 5075. First of all, thanks for all the reviews that you get, and yeah, I make an update up to today, according to what I see from the concerns that John and you and I'm sorry, I forget how to pronounce another person that just joined the review. Yeah, one thing is that the thing that I haven't think about before is the way that we like turn disables and enables or like changing the flag of the consumable or like the share stuff while we already starting the cluster. So I add the sections for like handle the device update when we change the values of the allow multiple allocations flag or the shareable flags previously, and the sharing policy sections, like how we are going to handle for each case. And also update the test plan for readability. Previously, it just lists up all the test case, but I don't think it's easy to read. So I'm trying to list up the test case that I'm planning, or actually I have already implemented to validate that. It will include the part of the API validations, and it should cover what Patrick you mentions about like the minimum maximums in range, or like the options shouldn't be duplicate, or like the default should be in the options and so on. Those stuff are going to fall in this validation taste, and also the validation stuff as well. Also, the third thing is the Lionel. He's not here, maybe, I'm not sure. Lionel's and me will have a presentations about this CAP in the KubeCon Japan. We have prepared a demo version integrating this CAP 5075 with the device data stuff that Lionel has developed, and we are going to do the demos there. I will put the demo link here later. And also, yeah, I also update my implementations as well up to like the June pull. So yeah, you can see the latest update in that branch. It will separate the commit as Patrick you suggest me before, that the API update and the generated code and then implementation of scheduler. So I hope that this will be easier to like do a previous review if you want to. And also there's two discussions. I'm not sure whether it's already resolved or not in the CAP, because yeah, I don't see the final decisions. But the one is that the way we identify whether this device shareables or not, because it was raised up that actually the device shareables by partitionables device, so it might be confused to have this flagged. So we are thinking to change to allow multiple allocations to be qualified, that this fact to say that this device can be allocated multiple times instead of that, or like change into the enum for the future extensions. However, I would like to push the complicated into the capacity level, not the device level, like the strategies to handle, for example, to handle the default behavior, like what John raise up, like if the device has already allocated what we are going to do if we change the thing, or like what the Lionel raise up, like they want he wants the device to be hybrid, like sometimes it can be consumable, sometimes it's not, depend on the first consumer, for example, in the use case of their networks. So I would like to push that complexity of the allocations into the capacity level, and maybe not this scale, but we know that it can be extensible to the current API that pulls in this cap. Yeah, I think that is all I want to speak up here.
Okay. Yeah. We had Jordan review that cap, didn't we? Jordan Liggett as API reviewer.
And I don't know.
I don't remember. Yeah.
I just know the code name. The account is legit, so I think it's Jordan.
Liggett, yeah, that's Jordan.
Okay. Yeah.
I think he was okay with the Boolean as you had it at that time, and it was, I think, Samposhio who asked about the enum instead. So I think your current proposal with allow multiple allocation would be okay with Jordan. We have other precedences where we have used just a simple Boolean. So I think that looks okay to me. The ultimate decision will come when we do the formal API review, and then we can, yeah, basically call this out as an alternative that was considered and rejected. So basically saying we thought about using an enum and decided to not do it because ABC, well, mostly because it seems unlikely that we will need other modes. So that part is fine. And also what you said about allocation strategy, I think that responds to John's comments, and I think you covered that. So I need to look at it again. I haven't had the time yet, but overall, this sounds reasonable. Dominic, you were reviewing this cap for SIG scheduling. Is that correct?
Yes, you mean
yeah,
consumable capacity.
Yeah. So you are also listed as approver. It might make sense then to, I don't know, really just do another pass and just assume that it's ready for merging. Yeah. It sounds like it is. I personally haven't looked, but yeah.
Yeah, I haven't seen any major issues either. So.
Yeah. So product context, we still have 3 weeks before cap freeze, I think. Perhaps it's also only 2. So we should get started with really merging caps at this point, clearing out the ones that are in a good shape, not wait, because that will just make things pile up, and that doesn't help anyone. And I think this one is in a good shape. Pang has been working on this for quite a while, has been very responsive, so I'm happy with this one, even though I haven't looked at the latest incarnation. But yeah, product context, we have other things pending. The binding conditions, it is also asking for reviewers. I think Dominic, you were also looking at that one, right?
Yes.
Yeah.
The same story. I was focused on different things recently.
Yeah. I'd like to call out one new use case. I'm not sure if it's new, but it has come up recently, and that's CXL memory. So basically, Fabric attached memory that can be made available to a node based on a demand. And that would be another good use case for both caps, binding conditions and consumable capacity. because CXL memory can be modeled as a shared resource in the cluster. So basically a separate resource slice, not attached to any particular node, but with a node selector for the nodes where the CXL memory can be attached. Then the consumable capacity is basically amount of RAM, perhaps with some constraints. So this cap here that we just discussed perfectly describes also CXL memory, most likely. It might also have some attached limitations, like, I don't know. I'm that's really theoretic. I don't know if there are such limitations, but the number of nodes that can attach a chunk of CXL memory might be limited, and that could be another consumable capacity, basically a counter that gets decremented for each allocation. That also gets covered by consumable capacity. And then the binding conditions cap, that covers the part about making sure that the fabric actually is reconfigured to make that allocated chunk of CXL memory available on the chosen node. So both caps work pretty well together. My plan is to look at the binding conditions, look at this cap here. I might leave a comment about CXL memory in both caps. But it's worthwhile keeping in mind that this does indeed make sense. And I think that's more important for the binding conditions because the use cases for that one were a bit weak. With CXL memory, we would use it exactly as described. Most of the time, the binding proceeds through the happy path, and and it's needed because we do have this separate attach step for CXL memory.
Okay, so why is it different from attachable GPU?
For what? For GPU, it's different because what they want is to preserve the original DRA drivers unchanged.
Yes.
That led them down this path of having the original vendor GPU driver on the node, being completely unaware of attaching and detaching. And that's why they decided that by attaching a GPU and then pretending that the attachment didn't work and doing this complicated dance of allocating again now through the vendor driver. That's why it was so complicated the way they intended to use binding conditions. If they do what we have been telling them, and that is making vendor drivers either directly aware of attached devices or doing a proxy solution, then binding conditions also works for GPU with the happy path.
Okay, so memory doesn't have that.
With memory, you would have to have a CXL DRA driver, and it would need to support attaching out of the box. So in that sense, the on-node driver part knows that it needs to wait for attached memory. And that's different from current GPU drivers, which basically assume that GPUs are local. So that's the key difference between CXL and GPU. It's basically really the driver implementation.
Okay, so I think it's worth to mention. I think it's because the scenario how to do the attachment, how to do the discovery of resources that can be attached is important for our future evolution, because we should know more or less whether we can really rely on proxy-like implementations for attachment versus falling into problems like we have with GPU attachment.
Yeah.
One more comment about this cap. I also was reviewing node readiness. They have an interesting concept of action. What to do if the binding fails. So one of the action may be to taint a resource claim in case the binding fails, depending on what kind of failure happens. This way, we could address the problem what to do in the next scheduling cycle, whether to avoid picking the same resource or not.
Well, that's about binding conditions.
Yes.
My assumption kind of was that if binding fails for a node, yeah, it's pretty much the same. Basically, the driver then would need to update the resource slice eventually to indicate that the device isn't really available on a certain node. That's not a taint. It's really an update of the resource slice. And it could be done with yet another cap. The partitionable devices introduces different node selectors per device, and that could be used. So right now, a global network attached resource slice has at the resource slice level a node selector, and basically all devices in that resource slice must be attachable or available to all the nodes matching that global resource slice node selector. With the partitionable devices, it basically becomes so that the device itself has a node selector, and that node selector could be updated. So basically, the controller of a DRA driver that supports binding conditions, it sees a request to attach a device to a node. It somehow figures out that this doesn't work against previous expectations, and then it can update the resource slice, fail the binding conditions, fail the binding, and then the next spot scheduling attempt most likely will use updated information, or eventually will use the updated information. So that should be okay.
Okay, yeah, I was thinking whether really the next scheduling cycle then can see the updated resource slice.
Yeah,
so
well, it's not guaranteed. There is a race, but the binding can update the resource slice first, then update the resource claim status, and if it's kind of serialized in the API server, we kind of have a good chance that the resource slice update is seen first too. It's not the end of the world if it doesn't, because eventually the scheduler will see it. If the race could go wrong, but then we just have another pod cycling attempt where it picks the device that was the node that was previously rejected by the controller, and it will just fail again until eventually it will notice that it just can't use that node. But I think that's fine with eventual consistency.
So that's maybe fine for the current approach, but if we take a workload scheduling approach and we fail to schedule workload, then we do reattempt to schedule workload, still missing this piece of information. We may make workload scheduling, which is much heavier than just pod scheduling, inconsistent again. But we don't have to probably resolve this problem right now.
Yep. I'm taking some notes for my comments on the binding conditions cap. So yeah, this is you're right. The more likely we can make it that the next attempt is actually doing the right thing, the better. It's just a bit harder. It's just hard with the Kubernetes API design, where we really don't have a reliable communication path where it's all asynchronous. So. Okay. Yeah, I think that's.
Is there any other cap that we should look into from the array scope?
I don't have. Let me just go back to the board. Well, there is the just a second. There is, of course, my PR on the GA promotion. I did discuss that briefly with Sanpo Shiho, and he said that he's on vacation now and time limited soon. So as I knew that you were already looking at a few caps, I pinged Maxco, Machi, and he said that he's looking at this. So if you trust him to review this cap, we are fine.
Okay, I can sync with him.
Yeah. So basically, we probably need to load balance your time as 6 scheduling leads a bit between these caps. So I'm tentatively going with Marchi as approver for the GA promotion, but you're also welcome to look at this cap, of course.
Yeah. So we basically work together, so we can
yeah,
pretty often sync and discuss.
That's good. Yeah. We just as submitters of caps, we just need to know whom to ping, and we need owners. So but I think that's covered. Well, we can talk about this one here. You can see my screen. I switched the tab in the browser, so I'm now looking at the GA promotion.
Yeah, I do.
There was one problem identified with the scheduler plugin, and that is that we can't really guarantee a certain deterministic runtime of the filter operation. It just basically has to work on lots of different things. It might have multiple claims, multiple requests, lots of devices and resource licenses. We can't just say that the work is limited. It's basically a search, and complexity can work against us in some cases. So as a line of defense against runaway computation, the proposal is to add an overall timeout for the filter operation. I had discussed that with Sanpo Shiho on Slack before, and we kind of agreed that if we make it so that a filter operation for one node returns unschedulable, the scheduler will do the right thing if, say, for example, some other node finds a solution for the problem. The scheduler will then just continue with the other node.
Mm-hmm.
And another interesting case is if all nodes fail with unschedulable, we basically don't have a solution and the pod can't be scheduled. And that's also fine. It will get retried, most likely because some resource claim changes or resource slice changes. It won't get retried, and Machi pointed that out, if nothing changes. If the node was just busy and it didn't finish in time because the scheduler didn't get enough CPU cycles, for example, then it won't retry. But the timeout is so high that I think that's also acceptable. It's really it's really something, an abnormal situation that should never really occur unless something is working really against us, and I think that's okay.
Mm-hmm. Okay. And maybe one more thing about extensible resources. So I was looking into it yesterday. So I think creating resource claim by scheduler is acceptable for alpha. This is also Wojtek's opinion. I think that internal implementation could actually consider resource claim that is created before we enter the scheduling cycle and be used as if it was an optional resource claim.
Yeah. Okay. I'm glad to hear. Well, I opened the board. I actually don't see the pull request, so I need to check why it's not on our board. But yeah, I think we should go ahead as proposed and revisit. So yeah, let's definitely also move that one forward. It's actually one of the more important ones because it is something that people want to use to roll out DRA support in real clusters.
Right. So
Yeah.
the only comment that I have is the kind of implementation detail. We can even defer it for the implementation.
Yeah.
But internally treating it as optional could help to simplify the implementation. So potentially we may not need to have so many exceptions in the scheduling code.
Yeah. I agree about the implement. It actually was worse. I think it actually copied large chunks of the implementation into the CAP because there was a prototype and the CAP author thought that it would be useful to have that.
You can expand the comments. I think it will.
Yeah, I do. Well, yeah. Well, there are lots of them, so I can probably click hidden items quite a few times before we all.
I know, but I
all
think the conversation should appear.
Yeah.
I
Somewhere.
think it's this one.
Yeah. Yeah. Anyway, if we have consensus to move ahead, then I think we are fine. Well, there are more hidden comments. We also need to ask CAP author to squash because it's now lots of commits.
Yeah.
But yeah, let's move this one forward. And I'll make sure that it also appears in our board. I think it just lacked the working group device management label. Yeah, that's not there. It's just for 6. Why does it have all the 6? Oh, that's the implementation. That's the implementation PR. No, it's enhancements. Oh, sorry, I was confused. I'm still confused why it has all the different 6 as labels. That's odd, but yeah, well. Okay. Anything else? Any last words? I mean, we are all busy. If we can take half an hour back, that will make it easier to move all this work forward. And no objections, then yeah. Thanks everyone. Thanks Dominic for bringing these up. I'll try to. I did not capture notes, but I'll try to add something to the agenda doc to document what we talked about. And of course, the recording hopefully will appear soon for those who couldn't attend. Thanks everyone, and goodbye.
Thank you. Bye.
Thank you. Bye.